All right, so now we're going to talk about probably one of the more work and writing intensive things that you'll need to do in Algebra 2, and that is solving a system of equations that has three variables. So we've been working with systems of two equations, usually with x and y, but now what we're going to do is we're going to add a third dimension, we're going to add a third variable, and that is z. So my z's have a little line through them so that you can tell them apart from my 2's. And the general idea with this is what we're going to do is we're going to pick a couple equations to work with. So I'm just going to show you right now. So at first, I'm going to take the red and the green equations. So I've starred them. And we're going to put those two equations together, and we're going to get rid of one of the variables. And when we're done with that, we're going to come back, and we're going to pick the first and third equation, and we're going to do the exact same thing. We're going to get rid of the same variable. And in the end, what we're going to have is we're going to have two equations with two variables, which is still a system of equations, but you guys know how to solve those. And if you don't know how to solve those, go watch the video on how to solve those. So let's go ahead and get started here. So I'm going to actually order this. Number one here is step one. So I'm going to do my steps in blue. And so what I'm going to do is I'm going to scroll over a little bit. I'm going to take the first and the second equation, so the red and the green equation, and here's why. The z's right here are very easy to eliminate. Like I said on that last video on solving systems by elimination, I really like elimination. I think it's the quickest, easiest way to solve. So you'll see a negative 2z here and a plus z here. We're going to take these two equations and eliminate the z's. We're still going to have an x and a y, but what we're going to do is we're going to get rid of the z. And then we're going to do the same thing for the first and the third equation, get rid of the z, and then we'll just have x's and y's, and then we'll have two equations with two variables, which we already know how to solve. So, okay, so let's go ahead and just copy down that red equation. So 3x plus 2y minus 2z is equal to negative 4. So that's the red equation. The green equation is x minus 3y plus z is equal to 9. And so what we're going to do here is our goal is to eliminate the z's. So to get rid of those z's, what I'm going to recommend is that you multiply the entire second equation by 2. The reason I picked 2 is because we want to get this z to cancel or eliminate this z. The only way to do that is if you have positive 2z, because right now we have negative 2z. So a positive 2 will do that. So let's rewrite the green equation now that we've multiplied everything by 2. So we've got 2x minus 6y plus 2z is equal to 18. Remember, everything needs to get multiplied by 2 there. Okay, I'm going to move over a little bit. Scroll down. Let's copy that red equation just so we have them both right here in line with each other. So 3x plus 2y minus 2z equals negative 4. And so what I'm going to do now is with these two equations right here, I'm going to add them, and that'll get rid of the z. So I'm just going to take this second equation here and add it to the green equation there. All right, so 2x and 3x right here makes 5x. The negative 6y plus 2y gives us minus 4y. The z's will eliminate each other, and so I'm not going to put anything there. And then 18 plus negative 4 is 14. Okay. So right here is our first equation that only has x and y in it. And this is nice because all the equations we had before had a z in them. But this equation has reduced it so that we're just dealing with x's and y's. Okay? All right, so I'm going to zoom out a little bit here and go back. So we took the first two equations and we eliminated the z, and this is what we got. Now what we're going to do is we're going to pick another two different equations. So we can do any combo we want. We just can't do the first and second. Okay, so we can either do the second and third or the first and the third. We just can't pick the first and second again. And we're going to eliminate the same variable that we just eliminated. So in our case, we eliminated the z. We're going to come over here and we're going to ask ourselves, do we want to pick maybe the second and third equation or the first and third equation to eliminate the z? And you'll remember I picked the first and third equation to eliminate the z. And the reason for that is because we have negative 2z here and we have 4z here. So if we just double this red equation here, that would get us to negative 4z, and then it'll cancel with that orange z down there. Okay, so what we're going to do is we're going to come over here and we're going to do step 2 now. And that's a little big, so let's zoom back in over here. So we're going to do step 2 now. And I'm going to actually come over and just make a copy of this real quick. So bear with me. So I'm going to make a copy of the original equations. And we'll bring them over. And we're only going to deal with the first and the third one. So I'm going to actually erase this second one here. Okay, so now what we're going to do is our goal is to try to eliminate the z's. So in order to eliminate the z's, we're going to have to take the top equation up here and double it so that we can get that z in there to be negative 4z, and then it'll cancel with that orange there. So let's bring the red down. So I'm just going to draw an arrow down here. And the red equation is now, after we've doubled everything, 6x plus 4y minus 4z is equal to negative 8. So we've doubled everything, and now we've got these two equations right here, and we're going to work with those. Okay, so what we'll do is we'll add the second equation to the first one here, and by second I mean the third one listed here, but this is the second one, this is the first one, so we add it all together. What do we get? 4x plus 6x is 10x, 2y plus 4y is 6y, and then 4z minus 4z is just 0, so I'm not really going to bother with those. And then 22 plus negative 8 is 14. Okay, so now this right here is our second equation that has only x and y in it. So if I zoom out here, hopefully you'll be able to see that we're in a really good spot now, because basically what we can do is we can now take this equation, which has just x and y, this equation, which just has x and y, and we can solve those. We'll either solve for x or y first, but once we know x or y, we can solve for the other variable. So if we do x first, we can find y. Once we have x and y, then it becomes very easy to find what z is. Like, we'll probably just use the green equation over here. We'll just plug in x, plug in y, and then we'll be able to find z. Okay, so let's go ahead and do step 3 now. So I'm going to zoom in over here. And step 3 here is going to be, we're just going to write down our two equations here that I've put in pink. So the first one is 5x minus 4y equals 14. The second one was 10x plus 6y is equal to 14. And so what we're going to want to do now is we're going to solve this for x or y. So, and again, we're back to solving systems of equations. You can graph this, you can do substitution, you can do elimination. I think, personally, I would do elimination, and I would work with the x's. So you could work with the y's if you wanted to, but all we have to do is multiply this top equation by negative 2 to get this 5x to become negative 10x, to cancel with that. So let's do that. So I'm going to come up to the second equation and multiply by negative 2. And when we do that, let's scroll over here a little bit, give ourselves some room. When we do that, this new equation now is going to be, let's do it in, we'll just do it in white here. So it'll be negative 10x, negative 2 times negative 4y is plus 8y, is equal to 14 times negative 2 would be negative 28. So now that we've multiplied everything in here by negative 2, we now have two equations right here in this red box, and now we can just add them together. So let's do that. So we're going to add this second equation to the first one. So these x's will become 0. So I'm not even going to bother writing it. These y's here will become 14y. 6y plus 8y is 14y. And then 14 plus negative 28 is just negative 14. And at this point, if you divide by 14 on both sides, you should get that y is equal to negative 1. Awesome. So we're a third of the way there. Just kidding. We're actually way more than a third of the way there. I'm just saying we're a third of the way there because we only have one variable so far. Okay, so now that we know that y is -1, we can go back to one of our original equations here and solve for x. So it doesn't really matter which one, but let's just pick this first one here. Okay, so we'll do step 4 now. So step 4 is we're going to take the original equation, so 5x minus 4y equals 14, and we're going to use our knowledge that y is equal to -1. We're going to take those two things together and say that let's do this in pink here, 5x minus 4 times y, which is -1, better be equal to 14. And this will let us solve for x. So 5x, -4 times -1 is actually +4, is equal to 14. And now we're just doing some algebra. So I'm going to give myself a little more room here. -4 on both sides. And we've got 5x, the +4 minus 4 cancel, is equal to 14 minus 4 is 10. So if you divide by 5 on both sides, you'll get that x is 2. Okay, so now we know that x is 2, y is -1. The only thing we have left to do is to figure out what z is. So in order to do that, let's take one of our original equations. So I'm just going to copy one. So I just copied the green equation, and the reason I copied the green equation is because it's got a z all by itself. Once you plug in x and y and you subtract or whatever that stuff is, you'll have z. You won't have to divide or anything. You don't have to worry about fractions or anything. So we'll bring that down here, and then we'll do step 5. So we'll do step 5 here. And what we're going to do is we're going to use the green equation. We already know that y is equal to -1 and x is equal to 2. So we're just going to fill that information in now. So with the green equation, we've got x, which is 2, minus 3 times y, which is -1, plus z is apparently equal to 9. So 2 plus 3 plus z is equal to 9. So that would be 5 plus z is equal to 9. And if you subtract 5 on both sides, then you should get that z is equal to 9 minus 5 is 4. All right, so apparently z is 4. So now what we need to do, let's zoom out again, is we've got our solutions. Now we just need to check them and make sure that they actually work. So let me copy our original 3 equations. Okay, so I made a copy of our original 3 equations here, and we'll bring them down, and we'll do step 6 right here. So let's zoom in here, and we're going to say, so we're on step 6 now, and we know that x is, I actually forget, x is 2, y is -1, and z is 4. So 2, -1, and 4. So 2, y equals -1, and z equals 4. So let's check these. All right, so on the red equation, we've got 3x plus 2y minus 2z is supposedly equal to -4. And let's fill in our numbers. So we know x is 2, y is -1, and z is, oh, I accidentally put the z in there. 2z, where z is 4, is supposed to be, all right, so all that's supposed to equal -4. So let's check. So 3 times 2 is 6, minus 2 minus 8. So 6 minus 2 minus 8, is that negative 4? It is, so that works. Awesome. All right, how about the green now? So we're going to do x minus 3y plus z is supposed to equal 9. Let's check and see if it does. So x is 2, y is negative 1, z is 4. So let's check. 2 plus 3 plus 4, does that equal 9? It does. So we're good to go there. All right, and then last thing we need to check here is 4x plus 2y plus 4z is supposed to equal 22. Let's check and make sure it does. All right, so x is 2, y is negative 1, z is 4. So let's check this. This would be 8 minus 2 plus 16. So 8 minus 2 is 6 plus 16 is indeed 22. So it works. So our final answer then, so when you actually write this out, the way that you write out your solution is you give an ordered, not an ordered pair, but an ordered triplet. I don't know what the word is for that. So it's going to be 2, negative 1, and 4. You always label the x, then the y, then the z in that order. So that would be your solution. Okay, so here's another solve the system question. We've got 3 equations with 3 variables. And in this case, let's kind of go over the steps again, right? So what we're going to do is we're going to first of all figure out what variable we want to eliminate twice. And then once we've eliminated that variable twice, we'll have a system of 2 equations that we can solve fairly easily. And then once we know what those 2 variables are, we can plug in to find a third variable. Okay, so on this one then, we need to decide what variable we want to eliminate. So you can either work to eliminate the a's, the b's, or the c's. And they're actually, you can make a case for any variable here. I was looking over my notes from class last year, and I actually did a different variable than what I'm going to do right now. So I'm looking at these. So let's talk through each one. If you do A, I think A would be a pretty good option because you've got A here and negative 6A. I really like when I have positive and negatives, and then I can just multiply this to get to that number. So like we could multiply the top red equation by 6 here, and that would get us 6a, so the a's would cancel. I also like if you pair up the green and the orange equations here, you could do you could double the orange equation and it would get you 6a, and that would cancel with that pretty easily. So I think that's actually what I'm going to do. I just want to walk through strategically if you were going to do B or C, my thoughts on that. You could do B as well. You would maybe, if you do these two, like the red and the green, you multiply the green by negative 3. That would give you positive 3b here, and that would cancel. That would eliminate the negative 3b there in the red. You could also pair up the green and the orange. I guess you could multiply this by negative 6, and that would give you positive 6b, and that would cancel with those b's. You could do that. If you were going to eliminate C, maybe you could multiply the red by negative 2 and pair it up with the green, and then you could do the same thing with the orange, multiply it by negative 2, pair it up with the green. I think that's what I did in my class last year, but I'm actually going to go forward with the A's here. I kind of like those. So I'm going to actually number my equations here. So this is equation 1. This is equation 2 here, and then this is equation 3. And so what I'm going to do is when I pair these up, I'm going to pair up equation 1. Actually, hold on. Nope. Let's do equation 2 and 3 first. And then once we're done with that, we can do equation 1 and 2. Okay. All right. So the first step in this process is we're going to pair up equation 2 and 3. So I'm going to go ahead and rewrite equation 2. So that was negative 6a minus b minus 2c is equal to 20. And then equation 3, 3a minus 6b minus c equals 8. And the goal here, we said we were going to eliminate A. So if I'm going to eliminate A, then strategically, I think it would make sense to double the orange equation. So if we double the orange equation, we'll have 6A minus 12B minus 2C is equal to 16. I'm just going to recopy the green equation. So negative 6A minus B minus 2C is equal to 20. So I've doubled the orange. That gets me the 6A that I need to cancel with that negative 6A. So we've got our two equations. Let's go ahead and add. Let's add the green one to the orange one. So the A's will disappear. You have negative 12B minus B. That's negative 13B. Negative 2C minus 2C would be minus 4C. And then 16 plus 20 would be 36. Okay, so we've got our first equation that only has B and C in it. It doesn't have A in it. All right, so let's go back here. Let's backtrack. What do we need to do next? So we've got one equation that just has B and C in it. So now what we need to do is we need to pick another set of equations, not the second and the third one. So we're going to do the first and the second one, and we're going to get rid of the exact same variable. We got rid of the A here, so let's do these two and get rid of the A. All right, so let's bring that over here, and I'm kind of running out of room here, so I'm going to go ahead and write down those first two equations. All right, so step 2, we got our first couple equations are A minus 3B minus C equals 4. And then the green equation, I can move over and just recopy that. All right, so the green equation was negative 6A minus B minus 2C equals 20. All right, and the goal here was to eliminate the A's, so I'm going to recommend multiplying the top equation by 6, because what that'll do is it'll give us 6A, and then when we add, it'll cancel with that negative 6A there. All right, so let's do this. The red equation now, actually I don't want that line yet. Let's go ahead and multiply by 6. So we get 6A minus 18B minus 6C is equal to 24. And so now what we're going to do is we're going to take these two equations and just add them together. So we'll take that, add it. The A's go away, so you got negative B minus 18B is negative 19B. Negative 2C minus 6C is minus 8C, and that's equal to 20 plus 24 is 44. So here's another equation that only has B and C in it. It's gotten rid of the A. So now what we're going to do for our next step is we're going to take these two equations, so negative 13B minus 4C equals 36, and negative 19B minus 8C equals 44, and we're going to solve those. So the question is, should we solve for B or C? Well, it depends on how you want to do these. We can do substitution, we can do graphing, we can do elimination. I'm going to recommend elimination. I actually like eliminating the C's because all we need to do is multiply this top equation by 2, and that would take care of the problem there. So when we do that, I'm going to write this one in white now. So that'll be negative 26B. Oh, we got a problem. We need to multiply by negative 2. Don't multiply by positive 2. Multiply by negative 2, because that will get us the positive 8C that we want. Okay, so backtrack just a second with me. So that should be 26B, because we're going to do negative 2 times negative 13B. Then we need to do negative 2 times negative 4C, so that gives us plus 8C. Then we need to do negative 2 times 36, and that'll give us negative 72. Okay, so now what we need to do is we need to take these two equations here, and add them together. So let's do that. So we'll throw this one in parentheses, add them together. So negative 19b plus 26b, that is 7b. Negative 8c plus 8c, those cancel. Those will eliminate each other. And then, okay, 44 minus 72 is negative 28. And so now we've got 7b is equal to negative 28. So divide both sides by 7. And you should get that b is equal to negative 4. So we've got our first solution. All right, so let's zoom back out, see where we're at. So we've got b is negative 4. So now what we're going to do is we're going to come back up to one of these equations here, one of these pink equations, and use our knowledge of b being negative 4 to solve for c. And it doesn't really matter which one we use. I'm just going to use this first one we got here. So we'll go ahead and zoom in here. And we'll say step 4 is we're going to copy that equation. So negative 13b minus 4c equals 36. And we're going to use our knowledge of the fact that b is negative 4. So we also know, and we know that b is negative 4. So what we'll do is we're going to say negative 13 times b, which is negative 4, minus 4c is equal to 36. So negative 13 times negative 4 is 52, minus 4c is equal to 36. I'd probably subtract 52 from both sides here. So we are left with negative 4c is equal to negative 16. Scroll down a little bit here. All right, so if we divide both sides by negative 4, then we are left with c must be positive 4. Okay, all right, so now where are we at? We've got c is positive 4, b is negative 4, and now all we need to do is come back up to the original equations. We know what b and c are. Now we just need to know what a is. Again, it doesn't matter which original equation you pick, although I like to be a little strategic about my pick. If I'm trying to solve for a, you know which one looks the best to me? I'm going to use this first one because it already has a, just a all by itself there. Okay, it's not like I have to solve and then divide by 3 here or divide by negative 6. That sounds terrible. So what we're going to do is we're going to take that first equation. So this will be step 5 now. Step 5. And we're going to say, all right, so we know that a minus 3b minus c is equal to 4. And we know that b is negative 4 and c is 4. Right? Yeah, b is negative 4, c is 4. All right, cool. So we'll just write this in, and we'll figure it out. So a minus 3b, which is negative 4, minus c, which is positive 4, is apparently equal to 4. So a plus 12 minus 4 is equal to 4. Let's see, plus 12 minus 4 is 8, is equal to 4. Okay, cool. And then just some algebra here. Let's subtract 8 from both sides. And we've got that a is equal to negative 4. All right, so now we've got that a is negative 4, b is negative 4, and c is 4. And what you'll want to do is just go back and recheck those and make sure that when you plug them in, they actually work. So I'm going to make a copy of that. All right, so I went ahead and made a copy of the original equations, and I've written down what the answers are, and now we're just going to check that out. So we'll go ahead and zoom in here. All right, so for the red is saying that A minus 3B minus C is supposed to be equal to 4. So A is negative 4, B is negative 4, and C is positive 4. So let's see if this works. So we got negative 4 plus 12 minus 4. That's supposedly equal to 4. Is that true? It is. That works. Okay. All right, so the first equation works. And now we're going to go and do the second equation. So we've got negative 6A minus B minus 2C is supposed to be equal to 20. Does it actually equal 20? So A is negative 4, B is negative 4, C is 4. So negative 6 times negative 4 would give us 24 plus 4 minus 8. So 24 plus 4 would be 28, minus 8 would be 20. So that one works. And now let's check the orange. So the orange is saying we're supposed to have 3A minus 6B minus C, and that's supposed to be equal to 8. A is negative 4, B is negative 4, and C was 4. So this would be negative 12 plus 24 minus 4 is supposedly equal to 8. Is that true? 12 minus 4 gives you 8. Yep, that works. Okay, so the solution then, if we were going to write this out, we would say the solution is negative 4, negative 4, 4. All right, let's look at another example of solving a system. And the first step is we need to decide which variable we want to get rid of. So the nice thing is on this one that we could pick pretty much any variable here and it would work out pretty nicely. If you go with x, you could put these two together and you wouldn't even have to multiply. You could just add the green and red equations together. And then if you do the green and orange, you could just double the orange, and that would get rid of the x's. That would work. On the y's, if you do the green and red, you can just add them together. And then if you do the red and the orange, you could also just add them together. So that may be even less work. And then for the z's, if you want, you could maybe pair up the red with the orange and double the orange, so you get negative 2z. Or you could also pair up the green with the orange and triple the orange, so you would get negative 3z. That would work. I'm going to actually eliminate the x's. That's just what I'm going to do. So, all right, let's actually number these. So this is 1. The green is 2, and the orange is 3. Okay, so the first two that I'm going to pick are, I'm going to do these two, just because all you have to do is add them and the x's will get eliminated. And then the next one, I will do the second and the third. So I think that's the order that I'm going to do those in. All right, so step 1. We've got the red, so 2x minus y plus 2z is equal to 16. And then the green, we've got negative 2x plus y plus 3z is equal to negative 11. And we're just going to straight up add these because the x's are already ready to get eliminated. So x's will go away. Oh wow, this is crazy. So the x's go away and the y's cancel each other. So we're just left with 5z is equal to 5. 16 minus 11 is 5. Wow, okay. That's going to make this problem even easier. So here's our first equation that has gotten rid of the x. coincidentally, it actually got rid of the y as well, which is really nice. So, all right. Step 2 is we're going to take the green equation, so negative 2x plus y plus 3z is equal to negative 11. And the orange equation, x plus y minus z is equal to 0. And what we're going to do here is we're going to get rid of the x's again. So in order to do that, I'm going to multiply the second equation by 2, because that will get me the 2x that I need in order to cancel with the green equation. So let's just rewrite both equations here. So the green one's negative 2x plus y plus 3z is equal to negative 11. And now the orange one, if we multiply everything by 2, we'll get 2x plus 2y minus 2z is equal to 0. And now we're ready to just add these two equations. So we'll add these. The x's will cancel, which is what we were hoping for. Then we'll get 3y plus z is equal to negative 11. All right, so that right there is our second equation that has gotten rid of the x's. All right, so let's zoom back out, see where we're at. So now what we're going to do is we're going to take the two equations that we have. So we have over here we have 5z equals 5, and here we have 3y plus z is equal to negative 11. And we'll bring those two together, and we'll solve for y and z. All right, so step 3, we've got 5z equals 5, and 3y plus z is equal to negative 11. What's nice about this is we really don't need to do elimination or substitution or anything. Why don't we just take the 5z equals 5 and say, well, if 5z is equal to 5 and you divide by 5 on both sides, then isn't z just 1? So that's nice. So if you're ever in a situation like this, don't freak out. Like, oh, I don't have any y's. You don't need them. Just solve for z. Cool, so z is 1 then. And so if z is 1, then I guess we'll just move to step 4, just to keep it consistent with the other problems we did. So now we know that 3y plus z, which is 1, needs to be negative 11. So all I did was just take this equation right here, bring it down, and filled in a 1 where the z was. So now we're solving for y. So 3y plus 1 is equal to negative 11. 3y is equal to, if you subtract 1 from both sides, you'll get negative 12. And then if you divide by 3 for both parts, you'll get y is equal to negative 4. All right, so y is equal to negative 4, and z is equal to 1. So now all we need to do is take the y and the z that we know and come back over here, pick one of these equations, and plug it in for y and z to find x. All right, which equation should we use? Well, I'm going to actually use that first one right there. So I'm going to take the orange equation there. We'll bring it down here, and we'll do step 5. So y is negative 4, z is 1. I need to remember that. Y is negative 4, and z is 1. All right, so here's step 5. So we'll remember that y is negative 4 and z is 1. Right? I'm not crazy, am I? Okay, cool. All right. I forget things like that very easily. All right. For the orange, we're putting in x plus y, where y is negative 4, minus z, where z is 1, and that's supposedly equal to 0. I find it weird that the orange is slightly off because I copied the orange. Like, why is the color different? whatever. All right, so this is basically x minus 4 minus 1 is equal to 0. So x minus 5 is equal to 0, which means x must be 5. You just add 5 to both sides. Okay? All right. So that's that. And we'll move over here to step 6, which is just going to be to check our work. So what we'll do is we'll go grab the original equations and the x, y, and z, and we'll plug them all in to make sure they work. Whoa, that's not what I want to do. All right, it's being annoying here. I'm just going to copy that, and we'll bring it down. All right. And supposedly, I'll write these down before I forget, x is 5, y is negative 4, and z is 1. All right. So we'll come check these and make sure they work, and then we'll be done. So let's see. We need 2x minus y plus 2z is equal to 16. So let's plug these in. Apparently x is 5, y is negative 4, and z is 1. So what would this be? This would be 10 plus 4 plus 2. Is that 16? Yep. So that works. Next we've got negative 2x plus y plus 3z is equal to negative 11. Does that work? If we plug in 5, negative 4, and 1. So what would we have here? We would have negative 10 minus 4 plus 3. Is that negative 11? Yep, that works. And then lastly, we've got x plus y minus z. And that's supposed to be equal to 0. So 5 plus negative 4 minus 1, is that equal to 0? It is. So our solution then, the final answer, is always my favorite part. So our solution is 5, negative 4, 1.